Hello, happy December 19th. Today I'm going to be discussing one of the examples of the kind of precision that we need to perform our experiments and to accelerate our particles. Now, when we accelerate particles, we need to know a lot of parameters about the particles themselves. So for experiments like LEP, and like Barber and like Bell, where we have electron-positron collisions, we need to know the centre of mass energy. If we get that wrong, we'll get most of our measurements wrong, and we'll also end up colliding things at the wrong energy. And when we collide at the wrong energy, the rate of collisions decreases. Now, we also need to know what kind of energies we've got to make sure we can keep the beams under control, because these are going around these huge rings, and they vary slightly. We have to keep adjusting with magnets, so we'll have a magnet here and it will kick the beam back into position, so instead of going up, it will go back down the way it should do, so that when they collide head on, and so that we don't lose them off the side of a magnet somewhere. Now, there are lots of different things that can affect what's going to happen with these magnets. And one of the effects is actually the tidal force of the moon as it goes around in the sky. So the moon is passing by, and it's actually dragging the Earth with it. The Earth deforms slightly on the side facing the moon, in the same way that the tides go up and down with the movement of the moon. And this actually causes shifts in the magnets, it causes shifts in the beam parameters, and this must be taken into account. Now, this was noticed at LEP, and it's also been noticed at the LHC. You can actually see a periodic sinusoid shape in some of the beam parameters, and this must be taken into account. Now, at the LHC, we only really care in order to get the beams to behave themselves as they go around the ring, but at LEP, it changed the centre of mass energy. And that needs to be taken into account, because if you only produce a Z boson, you need to know what your centre of mass energy is. And so there have been many measurements made, and it wasn't just the phase of the moon that determined the centre of mass energy at LEP. For example, when the TGV train passed overhead, that would induce the magnetic fields, and that would interfere with the magnetic fields in the LEP tunnel, and that could actually affect the centre of mass energy as well. So the centre of mass energy at LEP depended on things like the phase of the moon and the timetable of the TGV. And that just shows the level of precision that we need in order to get these experiments to work. Anyway, I'll put some more information in the video description below, and I'll see you tomorrow.